A student investigate the reflection of light by a plane mirror. The student ray trace is shown full size in figure 1.1. Okay, so this is the figure 1.1 that we have on the screen, and what they're telling us, students has he has drawn line ln. Okay, this is the line ln, and he has labeled the midpoint as m. Okay, what we have to do, draws a line PR parallel to ln, and then actually, this is all the information the student has already done. Okay, they have plotted it here. What we have to do, on figure 1.1, we have to draw a normal ln at the point m. This is the point m. Extend the normal downward until it cross the PR. This is PR. So we have to draw the normal here in such a way that it will extend and it will cross the point here, and you will name that point where it crossed as Q. Let's do it. So what we need a scale. Normal is a perpendicular line. So I will keep the scale exactly perpendicular at point M, and I will draw it here with the dotted line. Okay, so this is a normal, and I have to name this point as Q. Okay, and yeah, we don't have to do anything else. Okay, let's move forward. In the next point, what they're telling us, draw a line 14 centimeter long from the point M at a 10-degree angle as shown in the diagram. Okay, and you have to name this point as O. Okay, so it should be 14 centimeter and it should be at 10 degree. And they have already shown it, okay, in the diagram. So you just have to copy that thing. Okay, I'm using a digital protector. This the angle is shown at the center of my scale. Okay, so you can use a protector and you can measure it. So 10 degree will be at this point. So I have to draw it 14 centimeter, right? Let me confirm it what they have said. Yeah, it should be 14 centimeter. So 14 centimeter line, it should be okay. So how I can 14 centimeter? Let me place it at zero. This is at zero exactly. And if I start from here, the 14 will be, yes, there you go. And we have to name this point as O. Okay. This line is 14 centimeter, and you have to name this angle as theta. Let's move to the next point. Okay, what we have to do now, they are telling again, there's a information that the student places the reflecting surface of the mirror along the line ln with its reflecting surface facing the bottom page with the center of the mirror at m. Okay, so there is how the mirror is placed, and downward it will be a reflecting surface. Okay, position a light source and slit so that the ray of light passes along the line OM. M marks two small crosses x1 and x2, a suitable distance apart on the reflected ray from the mirror. Remove the mirror and the illuminated slit. Okay, this is all the information that they have given us. What they're asking us to do, we have to, on figure 1.1, that is the above one, draw a line joining M to x1 and x2. And what you have to do, continue the line until it crosses the line PR and label the point where it crossed PR as T. Okay, so we have to make a line that will start from M, cross x1 x2, and it will cross this point, and we have to name that point as T. Okay, let's do this. So I will try to make a line that will cross these two crosses x1 and x2, and it should pass the M. as exactly accurately as possible. So it will be like this. Okay. So, and this point will be t. Okay. Okay, done. In the second part, we're done with this one. We're doing this second part. Measure the length A of the line QT. Okay, in centimeter. Okay, the A is QT and measure the length B of the line MT. So you have to measure QT and MT. First is the QT. QT is this line. QT is, if I zoom in, 0 is on Q, and which point is on, it's 1.5678. It's between 7 and 8. So I'm going to write it down 1.7, 1.7. Okay, and QT, and what was B? Let me confirm it. B is MT. So you have to make MT as well. So MT is, okay, let me place the 0 of the scale on the M. Okay, there you go. If you place 0 of the scale on M, I have 10.2, right? So it's 10.2. Okay. Okay, so there is a margin in this calculation. If you see the marking scheme, you can, they will accept your answer in plus minus one variation. Okay, if your answer is 1.6 or your answer is 1.8, in this range they will accept it. Same goes for 10.2. It can be 10.3 or 10.1 as well. They will accept it. Okay, so whatever you are mailing, you can write it down. And secondly, keep in mind whenever you are mailing on your printed paper, the dimension of that paper and the paper provided in the Cambridge exam is different. So you might get the different answer when you're doing the measurements. Okay, so don't be confused in this thing, because the paper's dimensions are different. What you are using, what the printer is giving you, you're printing most probably on the A4 paper, right? But the Cambridge paper dimensions are slightly different. Okay, so moving forward onto the D part, calculate the ratio R A over B, and you have to write it down in the value. So A was 1.7 and B is 10.2, and I have to calculate the ratios. So what I can do, A is 1.7 divided by 1.10.2, that will give me 0.16. Okay, moving forward, the student repeats the procedure in B and C for the values of 20 and 30. These are the two values they have given you. Okay, and the student state that R is proportional to theta. Where is R? This R and this theta, they are proportional. Student is saying, state if you agree with the statement, use values. Okay, see, when the theta was 10, the R is 0.6. Okay, so if I say when theta is 10, R is 0.16. When I change theta to 20, the R is become 0.33. What this thing is showing me, that when I double the theta, when the theta is 2 times, the R is also 2 times. So the R is also double. So they are proportional to each other, right? So you can say that. So the statement will be yes, increasing theta is also increasing the R with same ratio. Okay. Moving forward, suggest what the student can do to have more confidence in its an answer. So what you can do if you need more confidence, you can test with more values. So what we can do, we can test more values of theta to get more clarity. Okay. Part G, suggest one source of inaccuracy in this experiment, even if it is carried out very carefully. Okay, this is a light experiment. So one is the possible inaccuracy is so this is the light experiment, and you are measuring the angles in it, right? And it's difficult to measure the angle with the accuracy. Okay. Secondly, in each and every light experiment, there can be an error because you're not doing the experiment in darkness, right? So what you can say, experiment not done in dark room, so it's difficult to trace the light, right? And or you can say, as it was the we were measuring the angle of reflection, if you remember what was the case. So theta and r was measured, right? R was the distance, it was the ratio of the two distances. So what we can say, that small change in protector angle can cause large effect on A and B. Okay.